Encrypt and decrypt using PyCrypto AES 256. I'm trying to build two functions using PyCrypto that accept two parameters, the message and the key, and then encrypt/decrypt the message. I found several links on the web to help me out, but each one of them has flaws. This one at CodeKoala uses os.urandom, which is discouraged by PyCrypto. Moreover, the key I give to the function is not guaranteed to have the exact length expected. What can I do to make that happen? Also, there are several modes, which one is recommended? I don't know what to use. Skeptical. Finally, what exactly is the fourth? Can I provide a different for encrypting and decrypting, or will this return in a different result? Edit. Remove the code part since it was not secure.
Here is my implementation, and it works for me with some fixes. It enhances the alignment of the key and secret phrase with 32 bytes and 4 to 16 bytes.
You may need the following two functions, pad to pad, when doing encryption, and unpad to unpad, when doing decryption, when the length of input is not a multiple of block_size. So you're asking the length of key. You can use the MD5 hash of the key rather than use it directly. More, according to my little experience of using PyCrypto, the fourth is used to mix up the output of an encryption when input is same, so the fourth is chosen as a random string, and use it as part of the encryption output, and then use it to decrypt the message. And here's my implementation.
Let me address your question about modes. AES 256 is a kind of block cipher. It takes as input a 32-byte key and a 16-byte string, called the block, and outputs a block. We use AES in a mode of operation in order to encrypt. The solutions above suggest using CBC, which is one example. Another is called center, and it's somewhat easier to use. This is often referred to as AES Center. I would advise caution in using AES CBC with PyCrypto. The reason is that it requires you to specify the padding scheme, as exemplified by the other solutions given. In general, if you're not very careful about the padding, there are attacks that completely break encryption. Now, it's important to note that the key must be a random, 32-byte string. A password does not suffice. Normally, the key is generated like so.
A key may be derived from a password, too. Some solutions above suggest using SHA-256 for deriving the key, but this is generally considered bad cryptographic practice. Check out Wikipedia for more on modes of operation.
I am grateful for the other answers which inspired me, but it didn't work for me. After spending hours trying to figure out how it works, I came up with the implementation below with the newest PyCrypto DOMEX library. It is another story how I managed to set it up behind proxy, on Windows, in a virtual env. Phew. It is working on your implementation. Remember to write down padding, encoding, and encrypting steps, and vice versa. You have to pack and unpack, keeping in mind the order.
If you want to see more, listen to this Friday.